Find the real number k for which the product of these two matrices has no inverse. Kk for 2k times 2k for 3. Well, we want to know when this product has no inverse. Before we begin, let's just look at what an inverse is. If I have just a regular old matrix, and I'm going to call it A, B, C, D. And I'm going to say this is a matrix A. A inverse is equal to 1 over the determinant of A times, I switch these two letters, and then I would make these two letters their opposite. Now, if you look at this carefully, I want to know when A inverse right here will not exist. If you recall anything about fractions, 1 over 0 is undefined. So if the determinant of A equals to 0, then A inverse does not exist. D&E does not exist. So what I want to know is, when will this have a determinant of 0? Well, using some shorthand, matrix A, I'll call this, matrix B, I'll call this. The determinant of A times B is written in absolute value. Factoring, the determinant of A times the determinant of B is written like this. So what I'm saying is, I want to know when A times B equals to 0, or the determinant of A times the determinant of B equals to 0. So I need to find the determinant of A. The determinant of A is this times this, 2k squared, minus this times this, minus 4k, times the determinant of B. The determinant of B is 2 times 3 minus 4 times k. 4 times k. And we want to know, when will that be 0? Giving myself some more room, I could factor this right here, take out a 2k. 2k, and we have k squared minus 4, actually not minus 4, but k minus 2 times 6 minus 4k, that equals to 0. I could also factor a little bit more, 2k, k minus 2 times 2, 3 minus 2k. Using this property we learned in Algebra 1, that means that 2k has to equal to 0, or k minus 2 has to equal to 0, or 2 has to equal to 0, which is impossible, so we never worry about it, or 3 minus 2k equals to 0. Now all I do is solve for k. Divide this side by 2, k equals to 0. So if k equals to 0, the product will not have an inverse. Or if I add 2 to both sides, k equals to 2. So if k equals to 2, the product will not have an inverse. Now this I don't worry about. I subtract 2 on both sides. 3 equals to 2k. Divide both sides by 2. 3 halves equals to k. So the product will not have an inverse if k equals to 3 halves, k equals to 2, or k equals to 0.